Now that we've written our procedure, we get to run our experiment. And when we're running our experiment, we're gathering our data, and then we get to look at what does our data mean, and then share that data with our audience. And so this flip is all about gathering our data, what to do with it once we have it gathered, both in math form for calculating and creating graphs. So when we're recording our data, we usually record it on a data table, which is simply an organized way to document our observations about our independent and our dependent variables. So a place to record what we've observed. So this is an example of what that might look like. Here we have our independent variable, and here we have our dependent variable. So we've chosen the times of day that we're going to look at in this experiment, and we're measuring the air temperature at each of those times of day. Now, sometimes when we're gathering our data, we're going to find the mean, and the mean, or the definition of a mean, is the average of a set of data. So whenever we want to find the average, this is what we would use. We'll use this when there's not an outlier in our data. So we'll find the average when there's not an outlier in our data. In order to find the mean, we would add up all of our data points and then divide them by the total number of data points. So we add all the numbers together in our dependent variable, or in one trial of our dependent variable, and then divide them by how many numbers we added up. So for example, in this case, the mean of the air temperature, we would take 42 plus 46 plus 54, 61 plus 65, and divide it by 5 because we had 5 data points, or 5 numbers that we gathered. And that gives us a total of 53.6 degrees Celsius as our mean. Sometimes we're going to find the median, and we would find the median, or the middle number, in our data set. The reason we might find a middle number is if we're also trying to find an average, except there's an outlier in our data. And I'll explain that in just a moment. These numbers are not the best numbers to use that for, but I'm going to show you with this example. So to find the median, you're going to put all the numbers of the data set in consecutive order. So line them up from smallest to largest. In this case, the data already felt largest to smallest to largest. However, sometimes they could be scattered and you would need to rearrange them. Once you have them lined up in consecutive order, or smallest to largest, then you just find the middle number. If there happens to be 2 middle numbers, then you would add the 2 numbers together and divide by 2, or you would find the average of the 2 middle numbers. So for example, with this data table, we would line up our dependent variable numbers in consecutive order, smallest to largest, and then find the middle number, which happens to be 54. This data set is actually not a great data set to find the median for, because the numbers are all relatively close. We would do this when there's an outlier, or a number that is extremely different. So say this number right here maybe is a 20, which is significantly different than any of the rest of these numbers. And that would pull the temperature, in this case, way down. It would skew the average. For example, in January of 2019, the average temperature in January was fairly average, fairly normal, until the last 3 days, when the temperature dropped significantly below 0 for 3 days, and it pulled the average of the month all the way down a full 1.5 degrees, because those 3 days were so significantly different from the rest of the month. Other times you want to find the range so that you can describe the difference. So the range is the difference between the highest and lowest value in a set of data. So what is the difference in numbers from biggest to smallest, or smallest to biggest? To find the range, you simply subtract the lowest number from the highest number, lowest value from the highest value. So in this case, we would find 65 and subtract 42 to get a difference of 23 degrees. So we would describe that as saying this means that the temperature range is 23 degrees between 8 a.m. and 4 p.m. I would want to find this if I'm trying to find a range, or if somebody says, what's the difference in temperature in the afternoon compared to the morning? You would say there's a difference of 23 degrees. So this is what our data table looks like, and you're fairly familiar with these. They have a title. You put your independent variable on one side and your dependent variable on the other side, generally in 2 columns, and you give headers on both sides, making sure that those headers have units if they apply. So in this case, the degrees Celsius or degrees Fahrenheit, millimeters or milliliters would be appropriate units to place into that. You can use your data table to help you set up your graph. So when you're looking at your notes, I want you to add all of the specific parts that are important to include on a graph. A graph is simply a picture of the information that we're looking at. So when you look at your graph, I'd like you to go ahead and label all of these same parts on your graph. So an appropriate scale is talking about the numbers, or sometimes scale can be words across the bottom and across the side, and you want to make sure that that scale is separated out evenly. So in this case, they count by 20, 40, 60, 80. It doesn't say 3, 21, 42, 87. It counts in even increments across the side and across the bottom. You also want to make sure that the graph pattern or the picture that you've created, we call it the plot, is appropriate. So that means the type of graph. Are you doing a bar graph, a line graph, or a pie graph? And we'll talk about how do you know when to do those in just a moment. If there's a key or needs to be a key, you want to make sure to include that so that your reader can tell which lines mean what or which bars mean what. Include a title at the top, and then labels across the bottom and up the side. And you generally want those labels to be summaries of what your scale numbers mean. It should be a summary that's 1 to 3 words long that tells what the scale numbers mean. So how do I know what graph to make? There's 3 different types of graphs: a bar graph, a line graph, and a circle graph. So we'll go through them actually in a slightly different order than your notes guide tells you. We'll start with a bar graph, move to a circle graph, and then talk about a line graph. You'll see why towards the end. Ultimately, the 3 types of graphs, you decide which type based on the type of data that you're using. So if we're using a bar graph, then we are likely showing how often something occurs, and we're comparing groups of something. In this case, we're comparing grades and the number of students who get each grade. So you might have 21 students receiving an A compared to nearly 80 students, or about 80 students, receiving a B. When you're creating this type of graph, the x-axis gets labeled with what's being measured, so your groups go across the bottom, and then how often or the frequency that those groups have something occurring up the y-axis up the side. This is different from a circle graph because when we're using a circle graph, we're showing a percent of a whole. So when we're showing a percent of a whole, oftentimes our key or our tip is going to be that we see a percent sign. You're not always going to be making a circle graph if you see a percent sign. Sometimes you're comparing, but if all of your percents add up to 100%, then you are likely showing a percent of a whole. In this case, you're showing the same different pieces of information, but without your x and your y axis. So we have our title, you have your groups, and you have the percentages or the values written along the side. In this case, the key is written right on the graph. Sometimes the pieces of the pie are too small, so then you would make your key off to the side. Another type of graph is our line graph. You'll use a line graph to show a change over time. And whenever we're making a line graph, our time is going across the bottom. A lot of times we think about time being an hour or minutes or seconds, but remember that it could be days of the week, it could be months, it could be years. So thinking about any time we're looking at a change over any measure of time, you're likely making a line graph. When you're making your line graph, the time always goes on the x-axis, this bottom side. And then whatever is changing, your dependent variable, the thing you're measuring, goes up the y-axis. One of the ways to get you thinking about, should this be a line graph, is to remember, if there is time, make a line. Sometimes you're comparing when you have time, but a lot of times you'll be showing how something is changing over the course of time. So it gives you that reminder to check and see if something is changing. We'll discuss in class how to set up the scale on the side, or sometimes even across the bottom if you're trying to figure out how far apart to make your lines or your bars. But you can also read that in your notes guide as well.